Welcome to the fifth and final part of my video about async.net. In this version I'm going to give you a few tips that can hopefully help you choose to write better async code. One of the first and really most obvious ones that I often see is code like this. You call and await to get something, and then you have a separate call to await something else, and they're not depending on each other, and that means they're running serially. You wait for that one to run and then you run that one. If you do this instead, these two will actually run in parallel, and that's often what you want. This is, to be honest, really one of the real powers of async code, is that it makes it super easy to go and do multiple things in parallel. But people often write this code negating what I would say is probably the biggest benefit of async in most code. As if you've seen all of the videos, you will know that the thread starvation and the massive scalability in websites, I don't think most people actually need to worry about, but this is something that will make your code faster. This code is probably twice as fast as that code. Various other factors, obviously, but you know, and that's so easy to do, to speed up your code to do those kind of things. Now, when you take that up a little bit further, when you're parallelizing, I've just got a few slides to explain how you can make your code more parallel, but there's some pitfalls in that as well if you scale up this thing I just showed you. So imagine you have something where you have an enumerable of messages and you want to put it on a queue. So in this case, I just have a queue writer that does some async stuff. So a very naive and silly implementation would be, okay, I have a method, it takes the list of messages, and then I just loop through, and each one I write it on a message one at a time, and I wait it. And this, of course, is slow, because you're not getting any parallelization here. It's just one message at a time. And for example, in Azure queues, you will find if you need to write a few hundred messages to a queue, this becomes quite a noticeable delay. It does take time. So you might be tempted to do something like this, where you say, okay, well, I've got all of my messages, so what I'm going to do is I'm just going to use a bit of link magic to say, take all of the messages and send them all to the queue writer and give me back a list of tasks, and then I'll just sit and wait for them all. So now you have completely parallelized it. All of the messages are going to be written all at the same time, and Bob's your uncle. Unless reality is you're probably just taking your system down, because if you have, quite a lot of messages in that queue, you might be writing 5,000 messages out in parallel. Each one is going to try and allocate a socket. You're going to overload your network card. You're going to saturate all your bandwidth, and your backend is probably going to fail on you as well. So this is the kind of thing where you quite easily get into site down scenarios with that little bit of code there. So don't do that either. That's really quite dangerous, unless you're really sure that you're only ever going to have a few messages in that list. Even then I wouldn't do it, because things change, right? Good practice. This is based on Clemens Vasters. He's one of the Microsoft Azure Cloud guys. He wrote something on Twitter a few years ago. It's here, and this is basically a slightly adapted version of that. So unfortunately, it's a lot more complicated. You thought async was easy. Unfortunately, if you want to use it safely and performant, you've got to start writing code like this. So what we're doing, to explain, we're going to just create a list to store my tasks in. We're going to have a semaphore. In this case, we're using semaphore slim. You could use old style semaphores. It doesn't particularly matter. You're looping through all of the messages like before, but you are waiting for a semaphore. Semaphore is, funnily enough, a threading locking construct. And basically what this will do is make sure that you can only ever run up to 100 writes, or you can only ever call the queue writer up to 100 times in parallel. What we're doing here is we're using .continue with. So basically it says you write to the queue, and then when the queue writer comes back and says, yeah, I'm done, then you're going to release a semaphore, which means the next one that's waiting can then come through. So the first 100 goes in straight away, and then it starts releasing them as they finish. And then at the end, we just await all of the tasks. I should mention that some people don't like continue with. David Fowler had a little chat about it on Twitter the other day. So you can rewrite this quite easy to just do an await and then do the semaphore to release in there. I did do some testing on it, and I can't see any performance benefits in doing that. A continue with just makes the code a bit easier to understand. So, but that's up to your preference, really. So yeah, Whether you should use 100 messages, 250, that really depends on your circumstances, or 1,000. There are lots and lots of different variables. I tend to just use 100 as a sort of my default. But there's one more problem with this one. So imagine you had 1 million messages in that list of messages. The problem there is, so you might be reading out of a database on like a data reader or something, and you want to read the messages and then essentially think data processing code. You're reading a long list out of one system and into another system. Now, the problem with this method here that you can see on the screen is that every single message is going to be kept in memory until they're all done. And there will also be a task object created for every single message that will also sit in memory. Often that's not a problem, but if you're writing this for very large numbers, that will cause a problem. So in that scenario, you'll probably have to wrap this whole thing in something that batches it in, batches of maybe 5,000 or something. So again, unfortunately, it's not easy, but these are things you've got to do. So just to summarize, I think I mentioned it before, return the task when you can instead of awaiting it, covered in previous videos. Just something I've fallen foul of enough times. You've probably seen me in the video use things like .select and so on to easily create a list of tasks. It's very important you do call toList on it, because you will often find otherwise that when you do like the task await or the if you loop through all of the tasks to await each one in turn to do the exception handling, then they will actually run them again. So you're ending up running each task twice rather than once. So make sure you do the toList on it. When you use a task.whenAny, be aware that it swallows exceptions. So that can, that can be really quite a nasty surprise sometimes if you think that, if something throws and you think you're going to be told about it and handle it, that won't happen. A common mistake I often see is people thinking that task.run makes something asynchronous. It does not, okay? That means you're scheduling your code to run on a thread pool thread. It's 100% old school threading code. It's just that all of the async stuff uses the same syntax. So you can await a task.run call, but it's a threading call. It's not an async call. And finally, if you want to know more, Stephen Cleary is probably one of the foremost experts on this stuff, and his blog is absolutely incredible. Can't recommend it enough. Thank you very much for watching, and this is the last bit, so you're free to go now. Thank you.